All right, good morning. So your written test number 1, I just released the marks together with the feedback on the E-class. Please double check if you got any concern about the marks or you want to go over certain parts with me. I'm more than happy to do it, but please drop by my office hour, Monday, Wednesday, 6 p.m. in person. Okay. But if you really want to make an appointment, it's possible, but we can talk. Maybe approach me after class and then we can schedule something. And then your programming test number 2 will be on this coming Wednesday, right? It's going to start from 1 p.m., right? It's a programming test like before. So please make sure you come at time, and then me and the TA will actually set up the room and then let you enter the room. Oh, actually, for you guys, it's actually the second one. Sorry, beg your pardon, right? Anyway, so please look at the guide. It tells you exactly what time you should really attend. And then your practice test number 2, we held a review session on Saturday. So I'll try to definitely process the video. I'll try to release the notes and also the video recording. I said Tuesday, but I'll try to do that later tonight. I'll definitely prioritize that for you guys. So you still have one day to go over the recording if you want to. And for your lab number 3, I also released the solution already. Please also take a look because the equals method is definitely something you will actually want to go into. Okay? And then I'm also going to release your lab number 4, which is about inheritance. I'll release that on time as well. So lab number 4 arguably is going to be the most interesting lab, at the same time a little bit more challenging about inheritance. So please just look forward to it, and I'll release that on time. And one thing that's actually very important for you to also make sure you catch up, which is about exercises on tracing. So we already finished discussing the equals method and also assert equals last week. So if you go to the lecture site, so I put something here for your exercises. So if you just go to the ones about equals method, you can see basically from lecture 12 to lecture 15, right? This range over here. You will see there's one section here about tracing exercise, right? You can download this starter page over here. So that one just contains 2 sets of exercises about how you can use this assert equals, and also the second set is slightly more challenging. So that one is about how to do person versus person collector. Okay, give it a try. It's a very worth your time to try to trace them. It's definitely going to help you, not just in the written test, but also in the programming test as well. And if you want to go over some tracing together with me, I also put up some video over here, right? That one's a little bit long, about 1 hour, but you can choose. You can fast forward, or you can just pick the set you want to go over, or just spend the 1 hour. It's going to be worth your time, right? So that exercise there, I'm going to leave to you, right? So do consider. Okay, and then that's about the tracing exercise. All right, that's about it. Guys, any questions about the course? Daniel. Right, so I would say for lab number 3, I did mention that the deep copy and composition, we didn't really cover that officially in the class. Those are the kind of hands-on stuff that you can easily pick up, just from the programming. So I would say don't worry too much about the terminology. Since we didn't cover formally the terminology about composition, etc., I wouldn't test you directly on those terms. So what I would do instead is to really test the concept and skills that you're supposed to pick up from lab number 3. So your safest bet, just look at the maybe solution quickly on the lab 3 and then pick up from there. I think that's sufficient. Okay. All right, any other questions? All right. All right, so I would like to start. Maybe I'll skip the recap for today. So we cover everything about the equals method. So please take a look at the materials. It's going to definitely be covered in the coming test, written test, and also the exam. I would like to start fresh about inheritance. It's arguably the most important topic because it's about advanced OOP. You cannot really claim that you know about advanced concept about OOP without knowing inheritance in depth. So I plan to, including today, I plan to start, maybe spend about 6 or 6.5 lectures on inheritance. There's a lot to talk about inheritance. Maybe you learn about it, maybe from the first year, I'm not too sure, or maybe from the high school, but I'm pretty sure you learn something deeper from my coverage. Okay, we'll go from there. But for this week, we're going to still restrict ourselves to something rather kind of gentle. But starting from next week, we're going to do things about polymorphic array and also typecasting in the context of inheritance. So these are the stuff you definitely have to pay attention to and also catch up in time. All right, so that's kind of the plan. About 6 or 6.5 lectures to really do it. And then after inheritance, we should get about 3 to 3.5-ish lectures, in which case I would like to talk about recursion. That'll be the final topic for this semester. I think we will have learned enough for this course. All right, let's now talk about inheritance. The slides is already on the lecture site. So quite a bit to talk about. Let me just go over the topics very quickly. So first of all, let's think about why we need inheritance. I would like to start with some motivating example, which is going to be used as a running example throughout the lectures. So why do we need inheritance? Let's try to see how can we solve problems without inheritance. What's going to be the drawback when you don't really have the assistance of inheritance? So that's definitely the drawback you might get from non-OO languages like a C, or even if you just want to use the procedural part for Python, right? So it's the stuff you want to understand before you jump into inheritance. And then we'll talk about the very superficial level about inheritance. Just talk about how you can use a keyword super, and also how you can use a keyword extends. So these are the preliminary, right, or the fundamental, the keywords you have to learn. That's only about coding, but that's only about 1/3 of what I want to talk about inheritance. What really goes beyond that, you definitely have to learn as well. Okay, we'll get there. And then we're going to talk about static type, expectation, and dynamic types. So these should sound familiar to you since we already talked about in a more intuitive sense what these terms really mean. And also we did some example. So I'd like to revisit these three and then do it systematically and thoroughly this time. Right? We definitely have to talk about static type, dynamic type, and also expectation, especially when you got a rather complicated inheritance hierarchy. Not just about object and point v2, right? We're going to extend that context to make it more general. And then we're going to talk about polymorphism. Don't worry too much about exactly what that means. We'll try to look at examples before we generalize those examples into polymorphism. That's what we'll do. So polymorphism is definitely one important keyword you should really know. And there are many, well, I shouldn't say many. There are 3 main application scenarios. We're going to see how polymorphism is going to apply to variable assignments, first of all, and how we can pass polymorphic arguments to the methods, and also combined with call by value, and also how we can make the return type polymorphic as well. So these are the 3 scenarios we're going to go over. Dynamic binding, just about which version of the method that we're going to call. So we're just going to see when you have a huge or sophisticated inheritance hierarchy, there are multiple versions of the same method, like an equals method, like we talked about earlier. But now we're just making it more general, how you can handle something called dynamic binding, like a which version of method you're going to call, right? And also typecasting, right? We're going to see a new kind of exception. It's called class cast exception. So we got null pointer exception, we got array index out of bound exception, and now class cast exception. So the class cast exception also needs our attention as well. You definitely don't want to kind of memorize the rules I'm going to talk about beyond maybe the second lecture about inheritance. All those rules, or maybe, all those rules that I'm going to talk about, they are really based on something logical. So I'll try to go slowly in the beginning. So lead you to those logical reasoning is really important. All right? Okay, so I would like to start with, by the way, this fragment here is just something I kind of sent to you guys maybe last night. If you have a look at that, that's okay. I would suggest maybe after today, you can also go back to the early announcement I made last night just about this design exercise over here. Even though we start talking about this example already, it's still worth your time exercising for this example here. All right, so guys, spend about 1 or 2 minutes. Just read through this passage here. It is so important because we're going to use the same example for the coming 6 lectures a lot. Okay, so please take a look. Just get yourself familiar with the terms and then think about, without inheritance, how would you design your Java classes to implement this system here? All right, 2 minutes. You can think about how many classes do you need to implement this particular system, and what are they? All right, 1 minute. Also, when you think about, okay, for sure, different classes, also within each class, what kind of methods should you support, right? So this may well be just the conversation transcription, maybe from your dialogue with your customer about what they really want, right? So now you want to turn them into something workable. Okay, 30 seconds, right? So the goal is really just get yourself at least familiar with the terms over here, all right? And then we'll start talking about different solutions. Okay, 1 moment, and then we'll start talking about it. All right, let's have some introduction to this system here. So you can definitely think about how many classes or how you're going to implement it. I'm going to skip that part for the conversation to save time, right? So I kind of summarize about what your previous fellow students have been contributing about how they might implement the system. I'll give you 2 possibilities, but we're going to do something deeper. We're going to criticize on the design of the system. I think that's something you want to also hear as well. Okay, just before that, let's now go over this one together. I'm going to highlight some key terms for you. Overall, we want to develop a student management system. So you can definitely imagine that there will be a class called student management system. And we are going to store data about students. So you can think about this student here simply means we're going to have some kind of collection, array list, etc. Right? So you can think about the student here is going to correspond to maybe some array or maybe some collection. Now the question is, how many arrays do you need? That's one thing you want to think about, right? Could be 1, could be 2, could be multiple. Okay, we're going to get there a little bit later. And we say there are 2 kinds of university students. Whenever you talk about different kinds, that's a little indication about you may want to use inheritance ultimately. But we're going to, let's say we ignore this part here about using inheritance since we haven't learned about them just yet, all right? So we basically got students, right? So student definitely can be a class. So I'm just going to put a student here, students. So student can be a class. However, there are 2 kinds of students. Let me also distinguish between them. So they may be like a generic, like a general students, but there are also 2 different specialized students. So the first one is we got resident students, okay? And another one is non-resident students. So sometimes, often, I will actually use an acronym. So I'll just show to you. So for resident student, I might just say RS, resident students. And for non-resident student, I might just say NRS. So there's an acronym I'm going to use quite often. Just get used to it. All right? And then, so here we basically say both kinds of students. We're saying something that different kinds of students share in common. And then we talk about how they are different to each other. Right? So these are important things to grasp. Okay? What do they share in common? Both of them, they have a name, have a list of registered courses. Right? So here what we have is, so you can see they have the name, and also they got a list of registered courses. Well, when I say a list of registered courses, you can use that programming pattern we are so much used to up to now, right? You can use an array of courses. All right? In addition to it, you can also try to register. So both students, either resident or non-resident, they can register for certain courses. Okay? And also important, they can also calculate the tuition. Okay? So you can think about every student, despite your kind. You should be able to register and you should be able to somehow calculate your tuition and maybe get charged, in the later phase. All right? However, that's what they share in common. Now here comes the most important thing we got to pay attention to. Okay, so here you can say that you can see that for a non-resident students, what they are unique about is they have something called discount rate. because they don't really live on the campus, they can waive the fee about accommodation, they can be waived the fee of meal, let's say. So they will be apply some discount rate for their tuition, all right? This second kind is called resident students. Because they live on campus, they might be charged some premium rate for accommodation and for meals, right? Because it's simplistic, account for the reality. Premium rate, all right? So what we have highlighted, so we're trying to do some very detailed analysis of the problem, and then we try to implement our Java classes accordingly. This is pretty much what you guys will have to do quite often, maybe in the later courses, maybe in 3311, software design, where you have to come up with the classes. We're just doing a little bit of exercise to give you some feel, right? Let me summarize about what you should really know from this extract over here. So we should really have a collection of students stored in the student management system. That's class number 1. And then, so here it's debatable. Should we create 1, 2, and 3 classes? Or should we only create, for example, only the resident students and also non-resident student classes, only 2? It's debatable, but we're going to see different possibility, all right? So what both kinds of students share in common is they both have a name, they have a list of registered courses, they can both register, they can also be calculated some tuition. Let's say, for example, let's say resident student, non-resident student, they're both registered for one single course, and that costs them $1,000, let's say. In that case, the $1,000 is something what we call base amount, right? And let me highlight it. Base amount, in the sense that it's before either premium rates or discount rate is applied, depending on what kind of student you are. So in the case where we talk about non-resident students, some discount rate, let's say 25% off, in which case the non-resident student will be charged $750 from $1,000, right? As opposed to, if we talk about resident student, they might be charged some premium rate, let's say 1.25. In that way, they'll be charged $1,250, right? So you can kind of see the idea. Based on the same base amount for courses, it might be you have to apply either the premium rate or discount rate accordingly, depending on which kind of student you're talking about. All right. Any confusion from the intuitive sense about this example here? Anything? All right, good. Let me talk about 2 solutions without using inheritance, all right? Before that, let me talk about something that's going to be useful for you. Let's talk about design principles. We're going to use 2 design principles to evaluate the 2 solutions in Java without using inheritance. We're going to see that both of them are going to be suffer from some imperfection, but we're going to evaluate them. All right. Let's now go over the 2 design principles here. You can also see the written form also in the slides, but let me just summarize them. We can talk about them. Okay. So we talk about design principles. Okay, 2 of them. Number 1 is the design principle called cohesion. Okay, maybe you heard about this term before, maybe when you're doing your English essay, in which case maybe your teacher tells you that your writing should be cohesive. Kind of similar sense in the software development as well, but we'll see how the concept can be adapted to our context. Okay, let me just have some definition here. Cohesion in our context for OOP, what does that mean? That means the attributes and methods. The attributes and methods in a single class should serve the same purpose, whatever purpose it is you have defined. Okay? Serve the same purpose. Another way to put it, if you like, rather than saying serving the same purpose, they should be under a unifying theme. Should be under a unifying theme. Let's say, for example, let's go back to your lab number 2. If I'm trying to design a class for vaccine, all the attributes and methods I put there should be only to do with the vaccine itself, conceptually. I shouldn't put anything that's to do with maybe distribution center into the vaccine class. Everything in the vaccine class should be only about vaccine, strictly. If you do anything that's not so relevant to that particular class, you're violating cohesion, or you say that our class is not cohesive. For those of you who might be taking 2031, the C course or Unix course, this design principle in some way also match what the design principle for Unix. I'll just put it here, just for your knowledge. So over here, the Unix principle. For example, you may have the command ls, you have the command maybe cd, or you may have the command pwd, right? Individual commands. The idea would be for each command, they only do one thing and do it well. That's really the principle about cohesion, all right? You're not really trying to say for the cd, it's really trying to combine various things rather than just changing directory. Each command should do one thing and do it well. And do it well. So the key word over here is about do one thing. Exactly what that one thing is, of course, is subject to definition. So in our case, in each class in Java, you should also do one thing and do it well. Exactly what that one thing is, it depends on the theme you're defining for that class. Okay, we'll see example very soon. All right, so that's about cohesion. Conceptually, it's not too bad, right? Just make sure you only put relevant stuff in your classes. Okay, cohesion. Number 2. And that one there has a little bit more relevance to the helper methods that we spoke about in the OOP review. So it's called single choice principle. Single choice principle. So single choice principle is a very general one, so let's not worry about defining that completely generally. So a very specific scenario where you might violate single choice principle is when you have duplicates in your code, in which case you may want to use helper method to resolve it, right? That's what we said in the review. Okay, I'll write it down, and then I'll give you some definition. So single choice principle over here, single choice principle right here. Right here. Let me do it once more. There we go. Good. So a possible violation of the single choice principle is when you have duplicates in your code. Duplicates. If you have the same kind of fragment of code repeating over and over in your Java classes, then that means you're violating single choice principle. Okay? And now let's define the single choice principle. Because your software is not supposed to be fixed in the stone once it's developed, it should be subject to changes or evolutions. Whenever a change is to be made, a change to be made should impact a minimum number of places. Okay, very simple and intuitive definition. When I say places, what do I mean? So places over here, I might say a minimum number of classes or minimum number of methods, depending on how you see that principle, right? For your particular case. The places over here could be classes, or it could be just about methods. Could be, depends. It's a little bit flexible. And here, when I say minimum, right here. Minimum here, since I want to make a change, so minimum seems to be just 1, right? You got to make some change somewhere, right? So minimum, it cannot be 0. You cannot just make 0 changes to achieve a change, right? So it got to be at least 1. However, the minimum here is saying it does not always have to be just 1. It could be more than 1 as long as you can argue that you cannot do better. Not necessarily 1. but no more than necessary. No more than necessary. As long as you can argue that I just cannot do better. These are the minimum number of changes I have to make in order to make this single change. Okay. So that's about single choice principle. Okay, so these are the two design principles we're going to apply right away. Right? So I'm going to present to you two possible solutions to this particular student management system problem without using inheritance. For each one of them, we're going to judge them by cohesion and also single choice principle. So that can let us appreciate more. When you don't really have inheritance, very likely you may have violated a certain design principle. The thing is, sometimes even if you violate the design principle, your code might still work. You might still pass test cases, but we don't want to be this short-visioned. Having the code passing all the test cases only for now. Your software project should be subject to some long-term healthiness. You want to be able to have some maintainable code that's going to last for long. In that case, you better make sure you can satisfy as many design principles as possible. Especially cohesion and single choice principle are the very common ones. You definitely want to satisfy at least. There might be others which you will learn in 3311. All right, let's now see some example here. The first one here is very interesting. Okay. Let me just say some highlight right away, okay? So this particular design attempt, right, the first one, without inheritance, the design attempt right here, this design attempt essentially is how you would simulate object orientation in a language that does not support object orientation. For example, let's say in C language, which you're maybe learning in 2031, the C language does not have anything like classes or attributes or method call or context object, nothing. However, it is possible for you to somehow simulate the concept about classes, methods, etc. in C using like a struct or maybe like an address operator, whatever, right? So that's something you can do, right? So the design attempt number one, just for your knowledge, is really about how you can use, how to simulates OO usage in a non-OO language. For example, C. All right, so that's just an aside I want to point out right away. All right, and let's now try to look at how this solution will look like without inheritance. So we have basically only a single class. It seems like it's a good design because we only need one single class to cover. Let's not worry about student management system just yet, right? We'll talk about it a little bit later. Let's focus on students, which can be either resident students or non-resident students. We only need a single class in this design. So we have student class right here. And then for students, we got an array of courses. And also we got a counter, right? So these are very familiar to you. And then the most important attributes is here. It's called kind. What kind of student do we have? And here I choose the one integer. And we know that in Java, integer, is 2 to the power 32 possibility, like 32 bits, right? So here, I'll just write it aside. Integer here, we know that it's 32 bits. That means, in theory, it can encode 2 to the power of 32 kinds maximum to be encoded. But of course, we don't have that many kinds of students, so I'm using integer. Potentially, you can use a Boolean to say true is for resident students and false is for non-resident student. But I would say to make our software a little bit more extensible, we might have more than 2 kinds, maybe later. So I think using integer is a safe way to do. Storage is not really our concern. So using int is definitely fine. All right. Specifically, we're going to make right here, when kind is equal to just 1, that means we are talking about resident students. Okay, we have some assumption that we have to follow. And when the kind is equal to 2, it's going to be non-resident students. Okay, only these 2 kinds. All right, and then I'll visualize to you a little bit later. And let's talk about the other two attributes. So here we have premium rates. And also we got discount rate. They're simply double, right? It can be 0.5, it can be 1.25, etc., right? And we know from before, the premium rates right here is applicable to resident students. Discount rate is applicable to non-resident students, right? That's from our reading before. Premium rate is only applicable to resident students, but not non-resident students. Symmetrically, the discount rate is only applicable to non-resident students, but not resident students. So mixing these two attributes here. And we have our constructor here to initialize a student object here. And then we simply have to pass the kind, which we assume can be either 1 or 2. So the kind over here can either be 1 or 2. Okay, let's see some Java code to see how we can do this. Okay, so we can do something like, let's say, students. Okay, I would say RS, resident students, is going to be new students. I know it's going to be resident student, so I passed 1 right here. So I'm satisfying resident students. All right. And then I have second line, also students. And I'm calling the same constructor. I call this NRS. And then I have new students right here. And I'll put 2 here. All right. And let's see what's going to happen at the runtime. For RS, RS stores the address of some student objects. As you can see, dynamic type is going to be students. Okay, I'll just put capital S for students. And we know that for every student, we got 3 attributes. We got kind, we got premium rate, we got discount rate, right? So we got the kind, we got premium rates, and also we got DR, discount rate, 3 attributes. And the kind over here should be just 1. At some point in the runtime, we can set the premium rates over here. That could be maybe 1.2. At the same time, the discount rate over here is not applicable to resident students. So this part here, even though there's storage there, but it's kind of wasted. We should never ever try to set the discount rate for resident students. I'll put a cross over here, not applicable. Right? What about the other one? Similar, okay? So for NRS right here, so we got non-resident students, which is storing the address of, okay, let me put it here. The address of some student object as well, right here. And we have the same 3 attributes. We got kind, we got PR, we got DR, right? All the 3. So the kind is going to be 2 at this, in this case, right? Because non-resident student has a kind 2. And also we got premium rates, we got discount rates. So now for non-resident students, they have some discount rate. So for example, it could be, let's say, 0.5. On the other hand, their premium rates should not be applicable, right? Any questions so far, just about how we implement, the 2 kinds of student here? After this, we have the various methods we have to support. For example, let's say once we have got these 2, they can be used as context objects. So I can do something like, I can say rs.getTuition, which is one of the methods. I'll go over that in just one moment. And also, we have another one, NRS. I can also say NRS.getTuition. I'm basically calling the same method. Somehow the method itself, which we'll see, should be able to distinguish between whether the context object here is a resident student, in which case the kind is equal to 1, versus the context object is a non-resident student. In that case, the kind should be equal to 2, right? So the kind over here, 1 or 2, in some way, let us distinguish between the different kinds of students. So the kind variable here is the spirits of the first design attempt. Okay? Now, let's look at two methods, just as an example, and then we try to judge about this design. We don't really need any JUnit test cases, but based on these, we should be able to somehow use the two design principles to judge how appropriate this might be. The first one here, get tuition. Right here, right? Get tuition, right? So you can think about what we're doing here is we are basically initialize some variable, tuition, and then we simply just try to go over the number of courses and then try to add up the fee together, right? If you got multiple courses, just add up their fee. That's easy to do, okay? So this is what we call the base amount. Base amount. And it will be subject to either premium rates or discount rate, depending on the kind of student you're talking about. So here you can see we have some discrimination right here, right? I'm using the word discrimination because depending on what student we are talking about, we're going to charge them differently. It's just a policy that we're making up here. So you can see here, we say that if the kind is equal to 1, which will apply to this case over here. And we're going to apply the premium rates, which is right here. Or the kind is equal to 2. In that case, we're going to use the discount rate, which will correspond to the 2 right here, which will be 0.5, right? So you can see the get tuition here. It's not difficult. Calculate the base amount, which should be shared among all kinds of students. And then, depending on what kind of student we are dealing with in the context objects, we're going to charge them differently by applying either discount rate or premium rates. Similarly, let's say we got another method called register. Okay? Let's say hypothetically we have a policy, which is to say, if it is resident students, they can only take up to 6 courses. And for non-resident students, they can take only up to 4 courses. Just different, right? So depending on the kinds, yeah.
Sorry to interrupt, but for the argument just being integer 1 or 2, how come we don't use a Boolean for the...
It's a good question, yeah. So in this case, yes, I agree. So we only got resident or non-resident, only 2 kinds. Yes, using Boolean is going to make it work. But we are more thinking about in the long term. Because later on, we might decide to introduce more kinds of student. For example, it could be international versus domestic. In which case, Boolean would not be enough to encode more than 2 kinds. In that case, you may want some storage that can hold more. So that's why I'm using integer, which can hold up to 2 to the power 32. But we don't need that many, of course. Yeah. Boolean may not be sufficient. Might be okay for now, this current version. But for later extension, it's not going to be sufficient. Yeah. Good. Okay, for the register, we're going to do something similar. So we're going to say, if the kind is equal to 2, we have certain maximum. And if the kind is equal to 1, we have another maximum, right? Just depends on the kinds of students. Right? Any question? Just about the coding part, right? I think that we have given enough details for you to see, also kind of visualize how things will look like at the runtime. I can tell you that this solution will work, even though we are actually we're trying to simulating OO in an OO language. But we're just trying to teach you about the different ways of doing things. All right, so now we have to use the design principle that we spoke about earlier, each one of them, to criticize about this design here. All right? Let's start with the first one, cohesion. As far as cohesion is concerned, we only got a single class, so there's only one single class to check. Is the student class cohesive in the sense that everything we put over here is somehow relevant to a unifying theme? You may want to think about at a runtime, depending on the kind of student I'm creating. Let's say I'm creating resident students. In that case, am I utilizing all the attributes in a class? One thing, and also, on the other hand, if I'm trying to initialize a student of non-resident students, am I also utilizing all the attributes? If I'm not, that's a good indication we may not have satisfied cohesion. All right? All right? Let's see this. Let's look at the diagram here. Every student at the runtime must have both the premium rate and discount rate. Premium rate and discount rate. However, when we talk about a kind being equal to 1, we will only make use of the premium rates, whereas the discount rate here is simply not used because resident students does not have any discount rate by definition. Symmetrically, whenever we got the kind being equal to 2, we only have the discount rate being used. But for the premium rate, we never use it because by definition, the non-resident student only use discount rate, but not premium rates. So we are somehow merging two attributes that are not really relevant to each other, premium rate and discount rate. They're somehow mutually exclusive. They only belong to one kind, but not the other. So, but we're mixing them in a single class. So the class is not cohesive. All right, already done. But if you got any thoughts to share, please speak up. But meanwhile, let me just put down something here for you to think about. All right, so you can think about right here, these two, premium rate and discount rate, right? So they actually violates cohesion because for resident students, discount rate, which is this attribute here, is not applicable. Symmetrically, for non-resident students, the premium rates, which is here, is not applicable. But somehow you're mixing these two attributes over here in the same class. So what will be the way to resolve cohesion? Well, you better put it in different classes, right? Maybe one class is only for resident students. The other class will be only for non-resident students. Question?
So, I just want to know, by cohesion, you mean that all of the variables in the class need to be used? There shouldn't be any null?
That's one way to look at that, right? So cohesion, there are different indicators you can try to see. So in this one here, we somehow see the indicator that you have certain attributes not being used at the runtime. So that tells you that attribute may not be relevant at all the time. In that way, that's a good signal about violating cohesion. But I would say the more general way to judge this is to really think about, go over all the attributes of your class if you have some scope to design your own classes. Think about if they're all going to serve the same purpose. But in this case, we'll argue that it's not, because the premium rates over here, the first attribute here, this one here is only serving for resident students, but non-resident students. And this one here is only serving for non-resident students, but not resident students, right? So somehow you're putting two things that are mutually exclusive in the same class, right? Yeah. All right, so it's about cohesion, all right? Now, so that one, this design here, violates cohesion. What about single choice principle? Or put it another way, do we see duplicates here? Not here. The student class, only this part here is okay. There's no duplicates because we got these two attributes. But do you see any duplicates in these two methods here? They're supposed to do different functionality for student. One is to get tuition, the other one is to register. But do we see any duplicates here? Daniel?
Get tuition logic.
I would say when you see duplicates here, you don't have to worry too much about deeper logic. We're basically looking at the code. Are we repeating certain lines of code over and over between these two methods?
Yeah, so the return tuition times the rate is
But if you, okay, so for example, you can see this one here. That one is just being applied, get premium rate, right? And this one here is just by applying discount rate. So these are different. As far as these two lines are concerned, there's no duplicates. You may want to compare more between this method here and this method here. Are we repeating any structure? The if statement, okay, I agree. Let me elaborate on what you're saying. Your fellow student was spot on. Okay, let's see. Duplicate number one. So you can see that we have to check to see whether the kind is equal to 1. Here, we also need to check it. That's duplicate number 1. And then we also have else if kind equals 2, and also else if kind equals 2. Right? That one is just another duplicate. Basically, for every method you have, we have to decide what kind of student we are talking about in the context objects. But to decide that, we have to keep repeating the same if then else check. All right? And then we're going to put else if right here. Okay? That's another duplicate, right? So here we got duplicates number 1 and also duplicates number 2, right? So now imagine that you've got 5 kinds of students. You basically got to repeat the 5 if then else statements in every method to define, to determine which kind of student you have to apply. Let's see a little bit further. Let's say our software has to be extended at some point. Okay, let me just give you one example here. Now think about this question here. Let's say we want to introduce a new kind of students. Let's say when the kind is equal to 3. Let's say we talk about international student. How about that? All right. If we want to introduce this new kind, it's a single change we have to make. But how many places do we have to go? As far as the methods we have already got so far is concerned. Let me repeat the question again. Let's say we want to have a third kind of students. So whenever we say kind equals 3, that means international. So now we got to make sure all the methods will be adapted accordingly to handle international. So now the question is, how many places do we have to go to change it? 2? More than 1? Which 2? Okay, I agree. So you're going to change both methods. How exactly are you going to change them? Add an extra condition for else if, right? That's exactly right. Okay, I'm going to put it exactly, all right? So now for this method here, I have to add an extra else if. And then I'm going to say the kind equals 3. I'm going to do something. And then over here, I'm running out of space, but here you also got to say else if the kind equals 3, and then you will do something. All right? So now multiple places you have to make. You have to go for this one here and this one here. Themselves are duplicates. That's duplicate number 3. All right? Let me write it down, and then we'll draw a mini conclusion for you. So think about these 2 are also duplicates. It's more like a duplicate number 3. One more scenario for you to think about. Let's say we no longer accept resident student anymore, let's say. That means kind equals 1 is obsolete. So now what should we do? If I don't want to accept kind equals to 1 anymore, it's not possible. It's just not possible for a student to live on campus, let's say. In that way, how many places do I need to change? 1? 2? 2? Right? What should I do? I should, for example, get rid of this branch about kind equals 1. I also need to get rid of this branch about kind equals 1. All right? I got to go for multiple places. That's the important bit. All right? So what I have just illustrated is, since we got duplicates about checking exactly what a kind is between all the methods, so this duplicate here violates the single choice principle. All right? Okay, so they violate. Good design? No, because violating single choice principle. So this new design here, which is trying to simulate somehow OO, it will actually violate both cohesion and also single choice principle. Programmatically, it will work. Design-wise, it's not going to last you for long. It's not going to lead you a long way. So you shouldn't really choose that one. All right. Guys, any question about this one here? Okay, I'll take question and then I'll take a short break. Go ahead.
The question I have was like, I know they're repeating, but aren't like their results completely different? So shouldn't they be considered different like pieces of code? Like I know they're if and else if is repeating, but one is returning a value and one is assigning a value. Shouldn't they be considered?
Right. So I think we were really considering literally about what's being repeated. So you can think about this particular condition here is being repeated twice. Exactly what's really to be done inside the branch, that's not something of our concern, right? Just about the structure itself. All right, I think we should really take a short break and then we'll go over design number 2. All right, so let's take a short break. All right, so let's now talk about the second design. So the first design without using any inheritance, it violates single choice principle and cohesion. Let's see the second one. And we're still going to judge the second one without inheritance using the same 2 design principle. Let's see if that might have some improvement, maybe. I'm going to show you the slides very quickly. Just go over like I have a quick overview about the code, and then we're going to go into it. Okay. All right. In this case, we're going to get 2 classes as opposed to 1 class. In design number 1, only the student class, and we got an integer kind. In design number 2, we don't have the kind anymore. We split the classes into 2. All right. So the first class is called resident students. And then in the resident students, we still got the common attribute name, courses, the counter. And also, we know that only premium rate applies. So only put the premium rate here, only that. Okay? In some way, we're already resolving some design principle violation right away, right? To some extent. And then we got constructor here. And then we got register. And then we got get tuition, and in this case, we calculate the base amount, and then we apply just the premium rates. So whatever we do in this class is only to do with resident students. Okay? Symmetrically, we have a second class, non-resident students. These 2 classes have nothing to do with each other. All right? And here we are having name, courses, NOC, right? Because non-resident student is a student, so they should have these attributes. But specifically, the non-resident student has the discount rate, not premium rates. So we only put discount rate here. Right? And then we got constructor, we got register. And here for the get tuition, the way we calculate the base amount is the same as before. But we have to make sure we apply the discount rate. All right? So now, before I dive into iPad, anybody would like to draw some conclusion right away? This is the second design. We got 2 classes. Now, in terms of cohesion and single choice principle, do you think we have made any improvement or we haven't? As far as you can see. If you know, that's okay. I'm going to go over in detail with you. Anybody would like to give it a try? Let's start with cohesion. Do you think this second design with 2 classes, are we satisfying cohesion? Meaning that every class has only the relevant attributes and methods only. We don't have any attributes that's somehow not applicable in some runtime scenario.
No, it's not cohesive because both classes probably have had the register method.
I mean the register, oh, okay, let's make that assumption there. Let's say register here, we don't have any, like a cap, like a different, like a constraint for the cap. Let's say they are the same. I know what you mean, because from the design number 1, I did try to say the maximum should be 4 versus 6, right? I could have done that in here, but I'm just making it a little bit simpler. Let's say we don't have any difference for this for now. There's no difference between what should be the cap size for resident versus non-resident student, let's say. Anyone else? Yeah, go ahead.
I think it is more cohesive because they each meet with their own requirements instead of trying to handle
Kind of collapsing them, right? That's good. Okay, I agree with you. So let's now try to look at it more closely to convince ourselves, right? I put these two classes in parallel right here. All right. Let's take a look at them very quickly. So you can see that we have, first of all, we got the class resident students. I also got non-resident students. First of all, we should know that these two classes are not related to each other whatsoever. Okay, so these two are not related. Oh, actually, yeah. Oh, thank you so much. I forgot. There we go. Right, over here. So these two, we actually got, they are completely independent of each other. Okay, over here. So these two are separate, unrelated classes. Separate, unrelated classes. Okay, let's start with that. And then let's dive directly into cohesion issue. We got premium rate right here, no discount rate. And here we got discount rate over here, but no premium rates. So we have exactly what's needed for that particular class under the name, either resident students or non-resident students. So these two tells us that we got cohesion. So that's a check mark. So we definitely make some improvement in this particular design without inheritance. At least it's cohesive right now. Now the question is, what about single choice principle? And the way to judge single choice principle is, do we have duplicates? Well, quite obvious, right? We got a lot of duplicate here, right? If we see between the two classes, let's see, right? Now, let's see here. The register method here and this register method here are completely the same, right? And also, for the get tuition, the way we calculate the base amount, everything except for the very last line. And also the way we calculate everything except for the last line over here. So that's completely duplicated, right? So, and also, more than that, you can see the attributes right here and the attributes right here, they're also identical. Even more, you can see the implementation here for the constructor and the implementation here for the constructor. Also duplicate. You basically got duplicate except the declaration for the premium rates and also discount rate. Other than that, everything else is duplicated. Right? But at least we improve the cohesion. So it's not a bad thing, but we still suffer very badly from single choice principle. Right? So I'm gonna write it down over here. So all these, right? For example, let's say all these, right? For example, right here, just an example. So these we got duplicates. So violating single choice principle very badly. Okay, we're going to see some idea very soon. But let's try to visualize what's happening here. This design number 2 is also going to work at a runtime. It's still a workable solution. Again, we don't want to use this one for long term. It's not going to lead us very far because it got so many duplicates, right? Let's see some quick test right here. So over here, we're just creating 2 courses. So we got C1, we got C1 and C2. So C1 and C2, right? We got 2 different courses. Let's see, 2030, 3311, okay? So here we got maybe 2030 and also 3311. And then we simply say, let's say 500, just for now, okay? The fee will be 500 and 500, okay? And then we got 2 students over here. The first one, we have Jin is a resident student. After that, we set a premium rate to be 1.25, right? So that one there, we're basically initializing Jin over here, resident students. The premium rate is 1.25. And of course, you can also register the 2 courses to Jin, right? Index 0 here, index 1 there, right? That's something we did in the previous lab. Okay, that's for student 1. The next students. So here, let's say we got Jeremy, non-resident students. And then we'll set their discount rate to be 0.75. So what that one would do is, so Jeremy, right here, and then non-resident student, dynamic type. And discount rate, 0.75. 0.75. Let's say these two students are classmates. So index 0 go here, index 1 go over here. That's exactly what these two lines of register method call, right? Not bad. And then let's now talk about these two. When we say Jim.getTuition versus Jeremy.getTuition. Jeremy.getTuition. All right? Let's now revisit what we said earlier about equals method. So here we got two versions, right? We got two versions of the getTuition method. Either the getTuition from resident students or the getTuition from non-resident students, right? So now which one should we call? We look at the context objects. So for this one here, Jin is a context object, which has a dynamic type, resident students. And when I go to the resident students, I got this one over here, getTuition. And that one there is going to calculate the base amount right here, which is going to add up 500 and 500, 1,000. And then apply to the premium rates, which is 1.25, right? So that one there is going to give us 1,000 multiply 1.25. Of course, you can do the math, right? What about second line? We're calling the method that seems to be the same method, the same name, but it's different. Because here, Jeremy, the context object, has a different dynamic type, non-resident students. That means we should go to the version that's in the dynamic type, right here. That one there is also going to calculate the base amount, right here, which means go over the array. That's going to be 500 and also 500, right? Following these two pointers and this one here. That one's going to be 1,000 multiplied by discount rate, which is 0.75. 0.75. Right? That's how things will work at a runtime. Because these two objects over here have different dynamic type. And also they have been set to 1.25 versus 0.75 for executing right here. So you're going to return different values for getTuition here and getTuition here. Right? So there should be no surprise about tracing this, pretty much like how we did it in the equals method, except there's no inheritance here. Questions? Okay, good. Let me give a little bit quick remark, and then we can move on. So let's just go a little bit more into single choice principle. Okay? Single choice principle tells you if you violated the student classes. We already said earlier, the student classes violates single choice principle. Right? That's what we said earlier. Why is it bad? Let's see one example. Okay? You will see that in the slide as well. Let's say, for example, we got our register method right here, which is completely duplicated with this method right here. Right? So currently, you can see there is not really a maximum bound about how many courses each kind of student can really register up to. Let's say we want to introduce that new policy. Let's say all kinds of students, they can only register up to certain maximum allowance. So this could be some constant. This can be, for example, 10, right? Or maybe 6, let's say. So every kind of student, including resident and also non-resident, the same, up to 10, okay? So now, since we kind of violate the single choice principle, now, if I actually have to do this particular change, how many places do I need to go? 2, right? I have to make sure I go here and also here. So this will be change number 1, I have to go, and this will be change number 2. Okay? I have to somehow include this particular check about if the student already registered 6 courses, they cannot do any more, like a 7th. That should be some exception. Right? So if I want to implement this new policy, I gotta modify more than 1 places. Right? So this one here, the number of changes you have to make is not minimum. The number of changes, number of places to make change is not the minimum. We'll see later. You just need one place if you design that properly. Okay, so that means it violates single choice principle. All right. Let's do one more thing about this design without inheritance, and then we'll see if we got enough time just to show you a little bit code about using inheritance. Okay. There's another one. You can definitely do this exercise. There's another possible change. Let's say the way we calculate tuition. Let's say we want to introduce inflation rate, for example. How would you do that? Do you have to only go to one place or multiple places? All right, think about the exercise. Should be somehow similar to what we said. All right. And let me now go on to this important slide over here. All right, so everything has been talked about. You just have to go through the bullet points here just to see a little bit more details to fill the gap. All right, so now slide number 11 is very important. Okay, so we already talked about the different student classes. We got resident student, we got non-resident student. Let's now think about student management system class, which is going to store the collection of all the students. All right, let's see. And I'm going to show you the code in a moment. I'm going to annotate it. But guys, I want you to show you some very important link, right? You will see that here, there is one link around the button here. It says a polymorphic collection of students. Okay, I'll tell you why this will be important. So this is the version about using a collection without inheritance, which we're going to do it today. And then if you click on that link, you will see that you will jump to slide number 83. All right, so maybe about 3 or 4 lectures later, we're going to reach this particular page to revisit how we can implement this student management system with inheritance. And that one there is going to look something like this. So later on, when you study for the exam, you have to compare slide number 82 and slide number 83 and the previous one very carefully. That one really tells you when you actually want to store a collection of objects, if you got inheritance versus without inheritance, there's going to be a difference to note. All right, but we'll get to 83 a little bit later, not now. You can also click on that and go back. Right, slide number 11 and 83. All right, so let's now talk about student management system. So now the thing is, how many arrays do we need? You might be thinking, maybe I can have an array of objects, like object, like an object class, right? Let's not worry about that solution. That one solution in some way has to do with inheritance, so that's not what we want. All right, let's now take a look at the code. Okay, right here. So this is a student management system without the inheritance. And then what we want to look at is here. We have resident students, we got non-resident students. They have nothing to do with each other. So that means we cannot store them in the same array, really. They're different types. It's almost like you got string, you got integer, like a different types. You cannot store them in the same array. So first of all, the resident students and also non-resident student, these two classes, this one here and this one here. These two classes are unrelated. That is why you have to store separately. And because you're storing them separately, you also need 2 different counters for them. So you got one counter for the number of resident students, another counter for the number of non-resident students. You cannot use a single counter because the number of resident students may be different from the number of non-resident students. You cannot use the same counter. They cannot share in general. And then you got different methods: add resident students, which will take resident students; add NRS, which will take non-resident students. Right? Let's say we want to have a single method here, register all. We want to register a common course. Let's say maybe, I don't know, maybe 10, 12, 10, 15, you know, like a common course for all the resident and non-resident students. We want to do that. since we have separate arrays for these students, we cannot use a single loop to accomplish this. We have to use one loop over here. Okay, I'll show to you. You can think about this loop here is going over the resident students array. And this one here is going over the non-resident students array. We're going to do them separately because they might be of different sizes. Let's say at the runtime, right? You have resident students array like this. You got non-resident students array in a separate array. And you want to go over them in different loop. So what we have is, think about this for loop over here is looking after this array. And this for loop here is looking after this array right here. Okay? So you can see that here we only got two kinds of students, only two kinds. And that already implies we need two arrays, two counters, two add methods, and two loops. Imagine that if you got 10 kinds of students, which might be realistic, there might be different kinds of students the university has to somehow accommodate. What does that mean? You might need 10 arrays, 10 counters, 10 add methods, and 10 loops inside the register all. That's a problem. So this here, without inheritance, also is not going to scale. All right, let me write it down. So here, without inheritance, there's a main drawback, even though it satisfies cohesion, but still pretty bad. Okay, this one here. The number of kinds of students is going to entail number of arrays you have to declare in the class, and also about the number of loops to write. For example, here you need a single loop and another loop, two loops. If you got 10 different kinds of students, you need 10 different for loops, right? So it'd be so nice if we can still keep the design cohesive, but we want to get rid of the duplicates. And also we want to make sure there's only a single array that we can store in the class. So the solution will be inheritance. So today we're mostly just focusing on how to really understand why inheritance will be so useful. But before that, we got to understand what about you don't have inheritance. When you actually dive into industry job later, it's no guarantee the language you're working with has inheritance support. In that way, you want to think about the different design possibility available to you and then decide which one to go. Or maybe you want to switch the language, for your implementation. All right, any questions? Okay, we got 3 minutes. I would suggest we do just a little bit more, okay, just to see. Okay, so now we have done two designs, right? The first design violates single choice and also cohesion. Second design right here violates single choice principle. But now we're going to see a solution that's going to satisfy both with inheritance. Okay, let me just give you a little bit like an introduction. Okay, we'll dive deeper into it also on Wednesday. Okay, let's just see a little bit more. We got 3 minutes. Let's see how much we can do. At least I can show you the keyword. So what we have is we have a students class. We have resident students. We also got non-resident student, 1, 2, and 3. You might be thinking, now, we're having 3 classes as opposed to either 1 or 2. It might seem not a very good idea, but I can say for only 2 kinds of students, this is okay, but it's going to lead us a long way. We're going to see. All right, let's go one by one. So first of all, we start with the student class right here. This is a class called students. Okay, so this one here is what we call a common superclass or parent class. Think about a student here is a little bit like an object class. And the resident student and non-resident student is a bit like a point V1, point V2, a little bit like that, okay? Class. And then we have 2 things over here. We got resident students extends students. And also we got non-resident students extends students. Extends is the keyword you got to make sure you learn. You're going to need that very badly for lab number 4, okay? So typically, this will be the syntax for extends. So extend is a keyword. Okay, and then there will be some name before extends, and there's some name after the extends. So whatever you put over here is the so-called child or subclass. And whatever you put after the extends is called the super, or parents or superclass. It's called the parents or superclass. Okay, so here you can see that resident students and non-resident students are the child classes. And the students and student here, they are so-called a common parent class. All right, I'll write it down. Okay, so here you can think about these two. So student here, and also student here. Okay. So here we are indicating students is the common parent class of resident students and also non-resident students. Okay, syntactically, that's what you got to do as the first step. So in your lab number 4 later, you will have to somehow at least decide which class should be the parent class and which multiple ones should be the child classes. Okay, give me 30 seconds and then we're done. So on Wednesday, we're basically gonna go over this again and just learn about the syntax and then to learn about the different keywords, and then we're gonna see exactly how to visualize about the inheritance and go deeper into it. All right, thank you so much, and then I'll see you on Wednesday.